2.2, absolute value function. Let's start with the definition. Absolute value of a number a is equal to the distance from a to the origin on the number line. So here's the number line, 0, 1, 2, -1, -2, -3, and so on. So absolute value of -2 is the distance from -2 to 0, which is 2. And also absolute value of 3 is 3, because that's the distance from 3 to the origin. Definition for absolute value function, we define it as a piecewise function, so it's x if x is greater or equal than 0, and negative x if x is less than 0. So since 0 doesn't have a sign, we can put the equal 0 either on the top branch or the other branch. Properties of the absolute value of a product, it's product of the absolute values. So we call this the product rule. And absolute value of a to the nth is absolute value of a to a power n. We'll call this the power rule. Absolute value of the quotient a over b is the quotient of the absolute values. Gotta make sure b is not 0. So we call this the quotient rule. And finally, if absolute value of x is 0, then x is 0. So this statement is written as if and only if, which means it works both ways. If x is 0, absolute value of x is 0, and if absolute value of x is 0, then x is 0. Now, if a number c is positive, we say the absolute value of x is equal to c if and only if x is c or negative c. If c is negative, absolute value of x equals c has no solution, because the absolute value of x being the distance is always positive. We're going to solve some examples of absolute value equations. A, absolute value of 3x minus 1 equals 6. So we're going to follow the rule here outlined. So based on this rule, think about c is 6, which is positive. So we can break down this equation into two equations, 3x minus 1 equals 6, and 3x minus 1 equals negative 6, and solve each one. So 3x equals 7, 3x equals 1 minus 6, negative 5, divide by 3, x equals 7/3, and x equals negative 5/3. So we got two solutions, 7/3 solutions, x equals 7/3, and x equals negative 5/3. Two solutions, you can plug them in and make sure that they work. Another example, number 2, 3 minus absolute value of x plus 5 equals 1. So we want to have the absolute value by itself. I'm going to subtract 3 both sides, and I have negative sign, absolute value of x plus 5 equals negative 2. Then I'm going to multiply or divide, doesn't matter, by negative 1. I'll just divide by negative 1 both sides. So the negative signs cancel. We have absolute value of x plus 5 equals 2. So this 2 is our number c from our formula here. So c is positive. So the solutions are what's in the absolute value equals to c, what's in the absolute value equals to negative c. So in our case, we're going to break this down into two equations, x plus 5 equals 2, and x plus 5 equals negative 2. And we solve each one, x equals negative 3, and x equals negative 7. two solutions, -3 and -7. Example 3, 4 minus absolute value of 5x plus 3 equals 5. Again, we're going to subtract 4 because we want the absolute value by itself. Negative absolute value of 5x plus 3 equals 1. I'm going to multiply or divide by -1 both sides. Absolute value of 5x plus 3 after the negatives cancel equals -1. This has no solution because the absolute value always has to equal to a positive number or 0. So we look here, if the number c is negative, we have no solution. And finally, graphing. So let's graph our parent function, f of x equals absolute value of x, which we defined earlier as a piece y. It's x if x is greater or equal than 0, and -x if x is less than 0. So we graph it on the coordinate system. We can make a table, or you can think the first branch is y equals x for x greater or equal than 0. So this is y equals x. It's a line with a slope 1 and y-intercept 0. Then we have the second branch, y equals -x for x negative. So we have this branch. So this is the graph of absolute value of x. You can make a table and take your time. Make sure you get this graph. This is a very sharp corner here, so it's not like the graph of the parabola. It's sometimes we call this the V function. Now that we know transformations, we can try to graph or sketch f of x equals absolute value of x minus 3. So from the parent function, which we know is absolute value of x, we need to shift it 3 units to the right. So that would become the same shape, the V function, but the vertex is at 3. One more example. Graph f of x equals absolute value of x minus 1 and negative sign in front of it. So again, the parent function is absolute value of x. The transformations we're going to do is down 1 because of the -1 and upside down. So the graph will look down 1 and upside down will look like this. So this is the graph of negative absolute value of x minus 1. And this concludes the lecture for 2.2.